We've talked a lot about /24s and subnet masks throughout this lesson. But what does it really mean? As we discussed previously, an IP address can be divided up into multiple sections. The first one is the network and the subnet. The second one would be the host portion of the address. A subnet mask separates a network from the host portion of the address, or tells us which part is the host and which part is the network. Both IP addresses and their network mask are presented in decimal notation. The subnet mask is usually referred to by how many bits in length that it is. For instance, if it's a /24, it means that the net mask is 24 bits in length. Interesting enough, a while ago, there were no net masks in use. So, how did devices know which bits of IP addresses were network bits and which ones were host bits? It all came down to the first octet rule. The designers of IP addresses divided IP addresses into the 5 different classes. The first byte of any IP address on the left determined which class an IP belonged to and how many bits of the address were network bits. Today, this is known as the first octet rule. This is demonstrated by the graphic below. Today, we still use the concept of IP address classes. That's why we refer to the network mask length as a /8, a /16, or a /24. It's worth noting, if your IP address uses the network mask length longer than the natural network mask used by this class, we call this a subnet. There are a couple subnetting rules that you should know. The first rule is that if the host bits in a given IP address are all set to 0, this is the network or subnet address. The second part of that rule is that if the host bits in a given IP address are all set to 1, this is the broadcast address. These are the 2 addresses that are reserved out of a subnet, one to identify the network and the other one for broadcasting. The second rule is we have to use this formula to calculate the number of available subnets given the specified length of the network mask. This formula is 2 to the power of s, where s equals the number of subnet bits. Rule 3 is that we should use the formula 2 to the power of h minus 2 to calculate the number of available hosts per subnet or network given a specific subnet mask. In this case, h is equal to the number of host bits. Let's see this example. Here we can see that our default network mask is a /24 because it takes up 24 bits. The extended bits are our 4 subnet bits. So if we follow our formula, we should know that we have 4 subnet bits. So the number of subnets that we can support is 2 to the power of 4, or 16. Now, in order to figure out the number of host addresses we would have in that scenario, we count the leftover host bits, which is again 4, and we say 2 to the power of 4, which is 16, minus 2, which is 14. So we can have 16 subnets, each with 14 hosts on them. Let's take a look at what that subnet would look like. Normally, we would have a 24-bit subnet mask, or 255.255.255. We would like to use an additional 4 bits for our subnet mask. If we use our binary numbering scheme to figure out what each of those foremost bits adds up to, it comes out to 240. So our new net mask would be 255.255.240, or a /28. Please join me for our next lesson, Understanding IP version 4 Subnetting Calculation Scenarios.